Hello and welcome back to Functional Programming Fridays with this Common Lisp series. You'll have to bear with me. It's taken a wee bit longer to get this sorted and set up as I would like. I lost the files on my computer, which are currently being restored, but that takes time. So if you hear me ruffling through my notes, it's because I've got paper-based notes, so all is not lost. And we said last week that we're going to have a bit of a review over two of the functions that we'd already looked at, the map and reduce functions. We're going to combine them here and have a look at a few examples and see how this MapReduce technique works, where you might use it, and a little bit of why. So before we get into all of that, we're going to have a very brief couple of minute recap on one of the map functions and what reduce does. So let's just dive into that. Map. We're going to use the mapcar function today. There we go. So if we mapcar using 1+ on the list of 1, 2, 3, 4, and 5, we get the list 2, 3, 4, 5, and 6. And we can define our own functions. There we go. So if we define this square function, we take this and we apply square. There we go, we get 1, 4, 9, 16, and 25. And that is us mapping over that list using the square function. Now we can extend this, and we're going to have a look at reduce. Where mapcar takes a list and gives us a list of exactly the same length back, reduce takes a list and does something with each of the values, accumulating them or folding them together to give us one value. So here, where we mapcar over the list of squares, and we're basically just summing the list of squares, we get 55, which, to prove that, totally not what I wanted to do there. There we go. We still get 55, so these two lines 10 and 11 are equivalent to one another, 10 hopefully being significantly more readable to you. So that's how map and reduce work together, and I appreciate that this is really a very small example, so we're going to have a look at how to introduce more complexity. And I'm going to pull an example that I worked on something similar in a previous company, just with all the sensitive stuff stripped out of it. So let's have a look and build up our understanding here. One of the things that I wanted to look at in previous videos, but I wasn't thinking, is I want to show you how we can use clos here. So we're just going to have our class here. Go, and we are going to add in a method for printing this out. So I'm going to say def method. I'm going to say print object, and this takes a object which is person, and it's a stream, and we'll say print unreadable object, which then takes a stream, and that then formats the stream. Let's take and then we're going to say name object and age balanced out there. I'm gonna, you know, just because that's always easier to work with. So one of the things that you have to make sure that you're doing is that you're using the backticks. To do that, we want to make sure that we've got our objects here. If we didn't use the backticks and commas, we'd end up with a list of symbols that represented the code to build up an object, but not actually the object itself. So when you're wanting a list of objects and you want to make sure that you are mapping over these, you want to make sure that you're using the backticks. Otherwise, you're not in for a good time. So all we are going to do here is we are going to use mapcar we're just going to get the list of names. So here we get Fred, we use the age, we get 25 and 35. So we can easily plug clos into this, as long as we are, again, using the right form here. Now, we might want to define a function for pretty printing. There we go, so we've got this pretty printing thing here, and we are going to print, not pretty printing. There we go. So we get this list here of Gary is 25, Fred is 35. Now what we're going to do is we're going to write a join method, which takes an A and a B. So now that we've got all this in place now, if we print out the result of reducing by string join the mapcar of printed people, we get Gary is 25, Fred is 35. So let's clean this up with some of our trivial examples here. There we go. Now, this might look like a very simple example, so what is going to follow in the next few minutes is I'm going to try and build up a slightly different example, and I'm going to build up a list of data . Going to be a list of URLs and hits. Be aware that these numbers are in no way going to be anything close to realistic. And be aware that I have omitted this hits here from this second deliberately. We're gonna treat this record as if it is in it's missing some data. It's been a while since I've seen Q. That went away many years ago. And let's stick with defunct search engines, I guess. There we go. So if we print this out, we'll see that we've got a list of 4 items here. 3 have this hits thing. The second does not. So what we need to do, and this was based on a bug in some real software that I was working on about a year or so ago. The front end, the JavaScript front end, if a user failed to click the appropriate box, JavaScript would send like undefined, and then our backend would parse that as being like 0 or omit it and just not build up a dictionary or an object hash map correctly. And we would have bugs where things wouldn't have the appropriate bits of data. So this is a down. I've taken all of that away, and it wasn't even written in Common Lisp. But this is based on a real flaw that we had. So what we could do is define fix missing hops, and this takes an object. We say if get object hop hits, fix missing hits. So if it does have that, we're just going to return object. Otherwise, we're going to return a new list, which is going to contain and hits to be 1. Because we're going to go with a default. So let's make Google like 5. There we go. So we've got this missing hits thing. I'm going to test it. So fix missing hits first. I'm just going to move that to the beginning of print. So that has not changed it at all. So we're going to say second. And that has changed it, where the second one does not have a hits, and so it's putting that in there. Although I will have to put a comma there. That's better. Okay. So we can now tell that this is working the way we would expect. So we've got this fix missing hits function. What we can do is print map car fix missing hits, and then passing data. We're halfway there. We've got this fixed up now. But let's say that we want to format our data by having all of the URLs joined together as a comma separated string and combine all the hits together. I'm not sure why you would do this, but nevertheless you might. Or we could have a single URLs list. That's probably better. And just a list of hits. So we're going to say define combine. And because we're going to use this as a reducer, it takes an A and a B. We are simply going to return a list here. And this is going to be an empty list. And we're just going to prove that it works, because I am a big fan of making sure everything is plugged in and we fix things up as we go. So yes, we got nil. That is exactly what we want. So we want to return this URLs, and we're going to say empty list. We're going to say hits 0. Cool. So let's start with the hits. We want to return the result of summing getf a hits and getf b hits, because a will get accumulated to it, and the way that that works together, we should put a comma there, of course, my bad. There we go. So we've got hits 11. So 5 plus 5 plus 1, that is 11. So that is correct. What we then want to do is we want to say get f a URLs or get f a URL, and that is us using the default behavior of getf where we can supply a default argument. So if there's no URLs in this plist, we can then get the individual URL. And what we then want to do is say append this with the get the URL. So we've redefined that. We have an error. Say list. So there we go. I just got my nomenclature a little bit wrong there. So yes, we are appending all of the URLs together. So we get this Google, go, QL, ask, and then we say between them there were 11 hits. So that is us taking a list of p-lists, so a list of lists here, and we're combining that all down to a single p-list, moving through map to turn each of these into corrected data so they all have a value somewhere, and then combining them all down into a single p-list by adding and changing, by returning a new p-list every time. It's a rather recursive way of thinking about it, or rather, it's a very functional way of throwing away the initial object and just pulling bits out and rebuilding it, but you see this a lot in the closure world, so that's kind of cool, and we can use the behavior of getf to return a default if there is not one. So on the first time we're going to return the list of the first one, and that will build a list which we can then pull back out, and then we get the list of URL here, and we're just going to add that together, because when we append, we need to append lists just like so. Otherwise we would get a const cell with 1, 2 and .3, so everything had to be in a list there. So that is an example of how map and reduce can be combined together. This, although it's a stripped down version, this was actually practically pulled out of a code base I was previously working on, where we can use map to fill in the blanks in some data that might be missing, and then we reduced that all down to something that we cared about. So that is it. That is a very, very brief look at how map and reduce can work together. I'm keeping it brief this week because of the problems that I'm having. My video recorder seems to dislike going over about 25 minutes of video time. So I planned this to make sure that we had enough time to go through the examples within 20 minutes or so, and looking at the time, we are coming up to that. So as always, if you have any questions, feel free to drop me a comment on Twitter or here in the comments on YouTube, and I hope you've enjoyed it. I really do appreciate the continued support that you're all giving me, the shares and the followings I'm getting. I really am appreciative of it. So take care, look after yourselves, and I will see you all in the next video, where we will actually introducing lambda functions, and we'll be seeing how we can use lambda functions to work with map and remove, delete and reduce. So please take care and